Hi there and welcome to this video series for Integrated Math 2. This is Lesson 2 in Unit 2 on quadratic functions. As always, we'll begin with our warm-up for today. So we've got these 5 problems here for you, so take a second and do those. Okay, so number 1 here, we have 6 times 1,341 divided by 3. If you look at it right away, you might think it's pretty difficult because you're trying to divide 1341 by 3 and then trying to figure it out from there. But one thing we have a choice of doing is actually dividing by the 3 first and then multiplying by 1341. So 6 divided by 3 is actually 2. So this is the same thing as 2 times 1,341, which we can double that pretty quickly, 2,682. Number 2. What is the y-intercept of y equals 2x minus 9? So if you know linear functions, you might just be able to quickly rattle it off, but let's think a little bit more deeper about this and why it is that way. So in this case, the y-intercept, actually in any case, the y-intercept is always the y value when x is 0. So we can just put in 0 for x and see what we get. So if x is 0, 2 times 0 is 0, 0 minus 9 is minus 9. So when x is 0, y is negative 9. So our y-intercept is 0, comma, negative 9. All right, and then next, number 3 here, we've talked about a lot about percents so far this year. But if you multiply the numbers involved, it makes it a lot simpler. Because what you would do, I mean, technically this is like 0.81 times 2, right? 81% of 2. But just multiply 81 times 2 and then move the decimal afterwards. So 81 times 2 is 162. But obviously 162 is not 81% of 2, right? That's way too much. So let's move the decimal and see what we can get from there. So we move the decimal once, we get 16.2. Is that right? No, still way too much, right? How about 1.62? That makes a whole lot of sense, right? So just using your number sense, you can kind of reason through why it's 1.62, which is a little bit quicker than having to, I guess in this case it's not too bad multiplying 0.81 times 2, but it does get a little more complicated in other situations. Let's see, number 4, what is the x-intercept of y equals 7x minus 14? So similar to this one over here, the y-intercept is the y value when x is 0. The x-intercept is the x value when what? When y is 0. So we can substitute 0 in for y, solve for x, and see what we get. So if y is 0, we can add 14 to both sides, and then divide by 7, and we'll get x over here is 2. So our x-intercept would be 2, comma, 0. And then lastly, number 5 here, our key features. We'll just talk about them real quick. Our y-intercept here, by the way, this is an absolute value function, if you remember from last unit. Absolute value function. Y-intercept is 0, 1 right here. The x-intercepts are 1, 0, and 5, 0. And then our axis of symmetry would be x equals 3 right here. And then our minimum value, in this case, is 3, negative 2. So hopefully you remember some of those key features of an absolute value function. All right, so let's go ahead and get into our lesson for today, in which we have 3 pretty large goals here. And this is going to kind of extend a little bit into our next lesson as well, but we're going to recognize the 3 different forms of a quadratic. As I mentioned last video, that's standard, vertex, and factored form. We're going to identify key features of a quadratic from those 3 forms, and then understand which form is best for certain characteristics. So certain forms reveal these characteristics a little bit more efficiently than others, and so we're going to figure that out today as well. So that's kind of our overview of our lesson for today. Let's go ahead and look at our first form, which is standard form. So standard form is the same form that we looked at last lesson, where it's in this general form. Now, keep in mind, A, B, and C are just numbers. okay? They're just constants. I'm just representing them with letters right now to hold their place, but really they're just numbers. So over here, A, B, and C are actual numbers, right? But this is like the general format that we can describe this in. So in this case, A is what? Yeah, there's like an assumed 1 here, right? So A is 1, B is -2, and C is -3. So this quadratic is an example of a quadratic in standard form. Okay? So we can tell certain things from standard form. So let's just kind of go through the list and figure out like what can we tell really easily and what maybe is not so easy. So as we talked about again in our last lesson, this value out in front here, do you remember what that determines? If it was positive, it did something. If it was negative, it did something else. Do you remember what happened? Yes?
Yeah.
What?
If it's positive, it opens upward,
If it's positive, it opens upward,
and
like concave up. If it's negative, that opens down. So the A value tells us the concavity. So I'm going to put A right here next to the concavity because that's what determines the concavity. B and C have no effect on the concavity. So if A is less than 0, that's a fancy way of saying what? If A is negative, it's going to be concave down. If A is greater than 0, that's a fancy way of saying positive, then it's concave up. All right, so that's the concavity. We can definitely tell that really easily from standard form. What else can we tell? Let's go to the y-intercept. Remember, the y-intercept is the y value when x is 0, right? So if we think about x being 0 here, if this is 0 and this is 0, well, 0 squared is still 0, and any number, it's -2 in this case, but it doesn't really matter what number that is because any number times 0 is still 0, right? So we're always going to be left with what?
or just lost.
Yeah, we're going to be left with 0 from these two parts, which means the overall y value that we're left with is, yeah, the c value out here, whatever that ends up being. In this case, it's -3. So the y-intercept we can tell by looking at the c value, so the y-intercept is 0, c. That's what it is. So the y-intercept on this one would be 0, -3. So that's not too bad, right? We can tell the y-intercept pretty easily just looking at the c value to see what our y-intercept is, right? All right, x-intercepts. X-intercepts is the x value when y is 0. So if we were to set this equal to 0, so put 0 in for y, and solve for x, we can figure out what the x-intercepts are. But at this point in time, in integrated math 2, we don't really have the capability of doing that. Okay? But some foreshadowing here. If we were able to do something called factor, if we were able to factor this and find the linear factors, remember last video we said anytime the linear factor is 0, the overall quadratic is 0? Same thing here. So if we can find out what these factors are, then we can really easily figure out what the x-intercepts are of this quadratic. But we're going to save that for later, but just know that we're going to kind of connect some things in a later unit there. So x-intercepts we can find, but not easily. All right? Axis of symmetry. Kind of goes along with vertex here. Those we cannot find easily either there. Okay? One last thing before we move on to the next form, though, is going back to the x-intercepts. I believe y'all looked at the quadratic formula before, right? Have y'all seen that at all? If you have, the quadratic formula can be used to solve this. If you haven't seen the quadratic formula before, then don't worry about it. But just want to throw that out there. So really two things we can find from standard form. Concavity and y-intercept. Very easily. Beyond that, it's going to take some work. All right, so we'll come back to these at a later point in the next unit. Let's go into factored form. Factored form looks like this, where we have y equals a, and notice that, wasn't there an a in this form? It's the same number. The a in this form, which in this case was 1, is the same value if you were to convert it to this form. Okay, so a there, and then x minus r. R in both cases are x-intercepts. We have factored form. So remember a minute ago I said if we could factor it, we could tell some other things. Well, sometimes you'll be given it in factored form. And so we're going to see right here in just a second what we can tell from that. So an example of this would be x plus 2 times x minus 6. What is a out in front? Positive 1. It really doesn't matter what it is as long as it's positive. Because that's going to tell us what again? What does a tell us? If it opens up or down, the concavity. So again, same thing here. A tells us the concavity. If A is positive, we open up. If A is negative, it opens down. So we can tell concavity both with standard and factored form. Let's see, y-intercept. Y-intercept is the y value when x is 0. So would it be too bad to put 0 in for the x's here? We could do that pretty quickly, couldn't we? 0 plus 2 is still 2. 0 minus 6 is still negative 6. What's 2 times negative 6? Negative 12. So our y-intercept here would be 0, comma, negative 12. So yes, we can find the y-intercept. I'm going to say, put here f of 0. Do y'all know that terminology? This is saying when you substitute 0 in for x, what do you get out? Which is what we did, right? This is saying that but in like symbolic notation. So f of 0 gives us the y-intercept. I'm just going to put a check mark here. We can find that pretty quickly. X-intercepts. We can actually do that really quickly in this form. Going back to what we said a minute ago, if we know the factors, we can tell the x-intercepts of the overall quadratic by looking at the x-intercepts of these factors. Remember our last lesson, anytime the linear function crossed the x-axis, the quadratic ended up crossing the x-axis? Same thing here. So what would be the x-intercept of this? In other words, what would make this 0? What value of x? Negative 2 plus 2 is 0, right? So that's the x-intercept of that linear function. What's the x-intercept of this linear function? What value would I put in here to make it 0? 6. So because negative 2 and 6, or negative 2, 0, 6, 0 are the x-intercepts of the linear functions, the overall quadratic is going to have those same zeros as well. So our x-intercepts are negative 2, 0, and 6, 0. This is what we call the zero product property, which basically states anytime that either one of these is 0, the whole quadratic is 0. So this idea that we've been talking about recently. So we can tell x-intercepts really quickly. I'm just going to put zeros of factors. So whatever makes the individual factor 0 is what makes the overall quadratic 0. It's not, I want to warn you that it's not always the opposite of the number. Let me give you an example. What if the factor was 3x plus 6? If you go with this whole opposite theme, you might say, oh, it's just the opposite of the number here, so it's negative 6. But negative 6 does not make this 0. Can anybody tell what makes this 0? What number could I put in here that would output 0 from the whole thing? Yeah, negative 2. So negative 2 times 3 is negative 6, plus 6 is 0. So negative 2 would be the 0 here, or the x-intercept. Those are kind of interchangeable, 0 and x-intercept. Okay, so we can tell concavity, we can tell y-intercept, we can tell x-intercepts, axis of symmetry. We can do this fairly easily. Let me explain how. So I'm going to draw a really rough sketch here of this graph. So we have x-intercept of -2, which is right there. And we have x-intercept of 1, 2, 3, 4, 5, 6 right here. Aren't those along the same horizontal line here? Meaning, if these are on the same horizontal line, isn't the axis of symmetry right in the middle of these two? So we can actually find it pretty quickly. So what's the midpoint of these 2 points, of -2 and 6? So overall it's 1, 2, 3, 4, 5, 6, 7, 8 overall, right? So instead I'll go over 1, 2, 3, 4, that's the midpoint there. So our axis of symmetry is right here at x equals 2. X equals 2. Does that make sense? The axis of symmetry has to be going through the middle of those two. Another great way to do this, besides like counting, is just average the two numbers. So 6 and -2. To average two numbers, you add them together and divide by 2, right? So -2 and 6. -2 plus 6 is 4. Divide by 2 and you get 2. So that's just kind of another way to get to that point. I'm not going to go into finding the vertex, at least the calculation of it, but what could we do? If we know the axis of symmetry is at 2, how could we find the point or the y value there? Yes? Yeah. Yeah, we would substitute 2 in, right? We know it's going to happen at this x value, right? So we could just put in 2 into the function and find out the output. So I'm going to say f, in this case, of 2, just substituting 2. What do you get out? That's the y value. And from there you can find the vertex. So right now, factored form is looking pretty good, isn't it? We can find a lot. The concavity, the y-intercept, the x-intercepts. Some of it takes a little bit of work, but we can find it. So we're liking factored form right now. All right, and then lastly, so we've talked about standard, we've talked about factored. Now let's get into what we call vertex form. What do you think is good about vertex form? We can find the vertex, right? It's in the name. So here is the overall standard form. Again, what letter do you still see up there? The A value. So we can still tell the concavity by looking at the same number throughout. So again, A is greater than 0, so it's positive, and it opens up. If A is negative, it opens down. Okay, so let's see what else. What do you think about y-intercept? Do you think we can find that? You think we can find the y-intercept? What can we always do to find the y-intercept? Yeah, put in 0 for x, right? No matter what you're working with, you can always put in 0 for x, find out what the y value is at x value of 0. So if x is 0, 0 plus 3 is 3. 3 squared is 9. So we have negative 9 plus 4 is negative 5. Yeah. Negative 5. So our y-intercept is 0, negative 5. And we just put in 0 for x, just like we always do. So our y-intercept, we can tell by doing exactly the same thing. F of 0 is how we do that. So yes, we can do that. X-intercepts, we're going to come back to that. It's not as easy. So really the only form that's really good at finding x-intercepts is what? Factored form. And as you saw a few minutes ago, if we don't have factored form, we try to get it in factored form by factoring. All right, axis of symmetry and vertex. Those kind of go hand in hand. Let's do vertex first. This is called vertex form because the vertex in this general form is h, comma, k. H, comma, k. So it tells us the vertex. It gives us the values of the vertex. So in this case, you see how it's a minus h? It's always going to be opposite of the number in here, or whatever makes the parentheses 0. So it's going to be negative 3, comma, and then k is out here, is the y value of the vertex. Now I don't want to just like tell you that that's the way it is. I want to show you too why those become the vertex, the values for the vertex. Okay, and then we'll come back to that here in a second. So, and then the axis of symmetry we know goes through that vertex, right? So in this case, it would be x equals negative 3. In general, it's x equals whatever the h value is here, right? It becomes that. So we can tell quite a bit from vertex form. The one thing that's probably hardest to get is the x-intercepts from that. There is a way, but it can be challenging at times. So we'll hold off on that for now. All right, let's go back to the y behind the way here, because I really want you to understand why negative 3, 4 in this case is the vertex. Okay, so let me start out with some questions here with you. So x squared. We'll actually do negative x squared for a second. What value could I input for x here that would maximize the output? What value could I put in for x that would maximize the output? Somebody just give me a number. What was it? 4? Okay, let's try 4. 4 squared is 16, right? Negative that, you get negative 16. Can anybody input a value for x that would output a larger number? Okay, something greater than 4? Okay, how about 8? 8 squared is 64. Tack on a negative, that's negative 64. Negative 64 is less than negative 16. So can we do better? 2? Negative 2? Okay, let's try it. Negative 2, in fact, or positive 2, right? Will give us the same thing. So negative 2 or positive 2, it doesn't really matter. Squared is 4. Tack on the negative, negative 4. Can anybody do better than that? So negative 4 is the greatest value we've gotten out so far. How about 1? Let's try 1. What's 1 squared? 1, tack on negative 1. That's better, isn't it? So we went from negative 16, then we got negative 4, now we got negative 1. Is there a way to get even larger value out? Yes. How about negative 5? Let's try it. Negative 5 squared is 25. Tack on the negative, you get negative 25. So we got negative 64, and then just now we got negative 25. We got negative 16, I think, negative 4, negative 1. So can we get larger than negative 1, meaning more on the number line to the right? Yes, any of you? 1/5. 0. 0.25. 0. Okay, so let's try 1/5 and let's try 0. So 1/5 squared, if you square a fraction, you just square the numerator and denominator, right? So 1/5 squared would be 1 squared, which is 1, over 5 squared is 25. So you get 1/25 out of this, tack on a negative, and you get negative 1/25. That's pretty good, right? But some of y'all said 0. Let's try it. 0 squared is 0. Tack on a negative, it's still 0, right? Is 0 greater than negative 1 over 25? Yes. And in fact, that is the greatest you can get. You cannot get a positive number out of this, can you? Because you're always going to tack on the negative. You cannot get a negative out of this to negate the negative and get a positive. So the greatest value you can get out of this is 0 by plugging in 0. So that's where we're going to start, and then we're going to add on to that. So what if we change it to x plus 3 squared. Same question. What value could we substitute in that would maximize the output? 0?
Yeah,
Zero,
-3.
0 here or 0 here?
0 for the difference.
0 for the entire thing? What are you going to say? 0 for the entire thing? So if we want this whole thing to still be 0, because that's what we said earlier, maximizes it, right? What value of x would we want there? -3. So inputting -3 created the maximum output, which is still what? 0. So here, 0 produced 0. Here, -3 produced 0. And these were both maximum values or maximum outputs of this, right? Last one here. Y'all stick with me just for another minute here, because we're going to do one more of these. X plus 3, so that stays the same, squared, plus 4. What value of x could I put in here that would maximize the output? Isn't this the same as this, which is a plus 4 out here?
Yes, so
So I'm adding 4 to every output of this, right? So if -3 maximizes this, then wouldn't it also maximize this?
yes.
But the output is different now, right? If you put in -3 plus 3 is 0, squared is 0, still 0 with a negative. 0 plus 4 is 4. So the maximum I can get out is by substituting in -3, by inputting -3, and the output is 4, which is why -3 comma 4 is the vertex of this quadratic, right? Its concavity is negative, so it's going to be opening downwards, so we're going to have a maximum at the top here, right? And that maximum is -3 comma 4 because that's what we put in to output the maximum value. So I don't want you to just understand that it's the opposite of the number in the parentheses. I want you to understand it's the value that makes it 0, because that's what either minimizes or maximizes the output. Right? So it's not just H and K. I want you to understand, why it is that way. Okay, so we're going to look more into this in our next lesson, and we're actually practice like graphing and those kinds of things with factored form, vertex form, and standard form. But just to recap, if we think back to our 3 forms, standard form was okay, right? It allows us to tell the concavity and the y-intercept. That's pretty good, right? But not great. Factored form, we were able to do everything except for, what was the one, vertex, right? But it wasn't too bad. We could actually find that. And then vertex form, we could find everything except for the x-intercepts pretty quickly. So there are some advantages to the various forms, but I hope that you've got a good overview of the 3 forms. And in our next video, we'll look at how to actually graph from those 3 forms and give you a chance to practice.